So in this video, I just want to make a quick note about some, a question that some of you might have, and that's, what if we made the charge distributions that we've been working with? What if we made them negative? We tend to work with positive charge distributions to, as examples and so on, and also later on to derive equations for the electric field due to each charge distribution. But you might be wondering, like, well, what happens if the charge distribution ends up being negative? What if it has a negative charge? So basically the exact same thing ends up occurring, the same pattern ends up occurring. So if you were to imagine this charge distribution as, being negatively uniformly charged instead, right? So instead of the pluses, you had minuses, blue minuses going all the way around. Then the only thing that would change would be that all of the vectors would point in the opposite directions. So this green vector would be pointing where the turquoise vector is, and the turquoise vector would be pointing where the green vector currently is, and so forth for all of the electric field vectors. So you still get that the net electric field at the center of this ring is 0. Likewise, down here, you'd end up getting the same thing. So by making the charge distribution be negative instead of positive, all that happens is that the directions of all of the vectors, all of the electric field vectors end up reversing. So if this was a uniformly negatively charged ring, then the net electric field at some point along the positive y-axis, that wasn't the center, right, because at the center it's 0, would end up pointing something like this towards the center of the ring rather than directly away from it. And again, this is just on the positive y-axis. I'm just drawing it over here with the beige point at the tail, right? So so something like this, right? Something like that. So anyhow, I just want to address that question because we do tend to work with these charge distributions as being positively charged, but if you're curious about what happens when they're negatively charged, basically the same thing ends up occurring, except that, again, all the electric field vectors just point in the opposite direction. So when we end up solving for like the equations to find the magnitude of these net electric field vectors and so forth due to these charge distributions, those equations, and we use a positive charge distribution to find those equations. Those equations still work for negatively charged charge distributions. There we go. It's a mouthful. The same equations still work. It's just you just have to reverse the direction of all of the vectors. So you just have to keep in mind that the direction reverses, but all the magnitudes and everything, which is what those equations are for, all still hold. So anyway, I hope that was helpful.